Hi everyone. I wanted to begin this Access module by giving you a brief overview of the concept of a relational database. Most of you will not likely have to do any work in a database or actually interact with the database yourself, but everyone that gets a job in business or anywhere else does interact with a database, whether you realize it or not. And data is stored in databases of all varieties. Relational is a very common type and one that we're going to focus on here. And so that's what Microsoft Access is, that type of database. And so we're going to use it to learn some fundamental concepts of relational databases. So first of all, a little bit of terminology. Data is stored in a database in a table. And a table looks kind of like a spreadsheet, where you have data organized into rows and columns, and the columns correspond to fields. You might think of fields or variables or columns. All of those are the same idea. These are just characteristics that we want to store. And then the rows then are records, a set of values, a set of field values for an individual person or thing that we're storing data about. So you can see in this little example of a patient table, every row corresponds to a different patient, and every column is a different attribute or field that we're storing data on for that patient. So the table is this collection of fields, and a record, one row of that table, is a collection of field values. So then a database is a collection of tables. So there might be a patient table and a doctor's table and an appointments table. And the collection of these tables and their relationships to each other constitutes the database. All right, so let's look at another example here and talk about some of the issues that come up. Let's say, and to motivate, why would we use a database as opposed to, say, just a spreadsheet? So here's an example where we're trying to keep all our data in just a single spreadsheet, maybe. So it looks like one table with a lot of data in it. And so here I have columns that look like employee title, last name, first name, employee date of birth, job, the job code and description for the job that employee holds, the base pay, the region of the country where this person works, the store they work in, and the year-to-date sales for that store. All right, so it looks like we're trying to do a whole lot of things in this one table. We're trying to store information about employees, about the type of job they have, about the region they work in, and about the store they work in. So some of these fields seem definitely to describe employees, but then some of them seem to be describing a store or something else. But we do want to know where the employee works, right? And what job they have. So the problem with keeping it all in one table like this is you can see a lot of redundancy. So we have multiple employees that hold this general support job that you see in this first row here. Several employees have that same job. So that job description we are storing over and over again. So that is a problem with redundancy. So it causes a lot of different types of issues in the database. Efficiency, lack of efficiency is one of them. But an even bigger problem is that we end up with anomalies or have the potential for that as we try to enter more data or edit data. Suppose an employee, their job description changes, and we want to change from, say, general support to secretary. If we have to type in secretary, are we going to spell it correctly? Or we add a new person, are we always going to type that job description exactly the same way? Is date of birth going to be entered using the same format every time? And so issues like this then cause us problems when we try to later ask questions of our data. We can have other issues as well, like let's say we decide to make changes about a store. What if a store closes and the employees associated with that store move to a different store? How do we find all the places where we need to change the store name and make that type of update to our data? So there are a lot of things that become very difficult to do, whereas it would be better if we had one place where we stored information about a store and one place where we had to change the name of the store, rather than finding every instance of the name Access Junction and changing that. And so you can start to imagine that there are problems created by this redundancy. All right, so the idea of a relational database is instead of all the data being stored in one big table that's trying to accomplish lots of jobs, we break our data up into multiple tables where each table is about a particular thing. And so by thing, I mean like think of nouns. Like in that table that we just looked at, we had employees. That was a thing we would be storing data about. Or stores. That's another thing we want to store data about. So then these tables need to be related to each other somehow so that we don't lose information. All right, so let's take a look at how we would do this here. Here we can see that some of these fields appear to relate to employees. So I would say the first 4 columns, employee title, last and first name, and date of birth, those all describe an employee. So those would definitely need to be in the employee table. The next 2 fields, job code and job description, seem to describe a job. So we could have a table that's just about jobs, and the base pay also, just about a job. Then region description, at this point that looks like the only field that's describing a region, but maybe we could just say that there is a west region and an east region rather than listing that multiple times. So let's have a region table. And then the last 2 fields appear to be describing something particular to a store. So we would have a store table as well. All right, so then we would split this data into 4 separate tables. And here's how that might look. So now we have a table that's just about jobs, a table that's just about regions, etc. And we've eliminated all that redundancy. So I don't have the job description, general support over and over again. I have it one time, and I know that that job has this job code and this job base pay. So I've stored that once. So now each table pertains to just one particular thing that we're storing data about. So another thing to notice here is that I did add a little something. In the region table, I said we just had to store these descriptors, but I added a region code so that we could uniquely identify each region by a number if we wanted to. And then in the store table as well, I added store code so we could uniquely identify every store. It's generally better to have your unique identifier be something that is not text-based, but that is just numeric. Okay, so the problem, though, is think for a second about what information have we lost. And going from one big table to 4 separate tables, we've eliminated a lot of redundancy, but we have lost some critical information as well that we had in that big table. So hopefully you are thinking, we've lost the relationships. We don't know this first employee, Mr. John Williamson. We don't know what job he has or what store he works in. For the Access Junction store, we don't know which region of the country it's in. All right, so we've lost the information that relates these tables to each other. So what we need to do, we need additional fields to store that relationship information. All right, so what we're going to do is add additional fields, and we need them where there needs to be a relationship. So, for example, an employee, to remember that Mr. John Williamson was a secretary, we need to store that job code for him. And then this code, SEC, relates him to this record in the jobs table. So now we know his job code, job description, and job base pay because of that common field between the two tables. That common field will relate these tables to each other. And then for every employee now, we could find out for that employee what the title of that job is if we needed it by going through that relationship with the other table through that common field. Another field that's been added to the employee table is the store code field. Now we know that Mr. John Williamson works in store number 3, which is the tuple charge store, and we know the information about that store. To the store table, we added region code so that we know which region each of the stores is in. So those additional fields help us maintain these relationships and keep us from the loss of information that we noticed previously. All right, so and that brings us to this idea of data integrity, which I've mentioned already, that we can have anomalies show up in our data. If we need to make changes, we have to change it in multiple places, that type of thing. So doing things this way, having a unique identifier for every record in a table, and then other fields that help relate the tables to each other, help us to ensure data integrity. So the first part of that is making sure that every record in a table is unique. So every record in the employee table should correspond to a unique employee. So we need one field that ensures that. And in the employee table, that's the employee code. Every employee has a different code. It's unique to that employee, and that helps us distinguish people. It's possible for two people to have the same name, right? They could have the same name and the same birth date. They could even have more things that are the same. So, and people's names change. So instead of using something that's unreliable or doesn't necessarily guarantee uniqueness, we can generate a unique code for each employee and use that as the unique identifier. In the other tables, we have something similar. There's a code that we can use. Even in the jobs table, there is a job code. Now here's one where we're using something that is text, right? And as long as we're comfortable with being able to guarantee that the code, that if we create a new code, just making sure it hasn't been used before, that would suffice for this job of making sure every record is unique. But it is typically easier and more efficient to use a numeric code. But you could potentially see either one. The other type of, and so the primary key is this field that is doing the job of ensuring that every record in a table corresponds to a unique person or thing. So the primary key in the job table is the job code. In region, the primary key is region code. In the employee table, the primary key is employee code. And in the store table, the primary key is the store code. All right, so the other fields that we added to manage the relationships between the tables are called foreign keys. So a foreign key is a field that holds values that are the primary key in another table, and it is a common field between the two tables. So the employee table job code is the foreign key, and it would be related to job code in the jobs table, where it is the primary key. So the job of the foreign key is to help us relate two tables to each other. All right, so in Access, you get to see this nice diagram view. This is in the database tools of an Access database, and you can see a list of the fields that are in a table, and then you can see how the two tables are related to each other. So the tables and their relationships are the majority of what constitutes a relational database. So that helps you see how we store data to control data integrity and reduce or eliminate redundancy. And if we have data that has integrity, then we can rely on it when we need to use it to answer questions in business. So I hope that was helpful and helps you get started on your assignments for this week.